The next part would be to calculate the scale of various components of our application that we need to design for. Let's start with the number of users we need to scale it for. Since YouTube is a globally used platform, let's start with the world population of 8 billion. YouTube is banned in some countries and doesn't entertain perhaps some of the age groups. So let's assume around 25% population uses YouTube. Every year the app will acquire more users. Let's assume that user base grows with 2% and that we want to handle this scale for next 5 years. Although these are the total users, the users that come back to our app daily are usually very less. So let's assume around 40% of the total users come back. The number is relatively high because YouTube serves a lot of purposes like education, music, gaming, game streaming, and a lot more. For next 5 years with 2% annual growth, we could need to scale the app for 883 million users. Now that we have a good idea of the scale we need to handle, let's evaluate throughput of our platform. We can assume that one user watches perhaps around 5 videos per day, so total average views every second would be DAU multiplied by videos per user and converting them to seconds. Two zeros would cut out to 8 million, 8 by 5 would be 40, and 24 by 36 would approximate to 1000 just like before. This would cut millions to make it thousands, which would come out to be around 40,000 requests per second. There will be days when content would go viral, so to handle that, let's support our app for 5 times the traffic. For this, we need to handle 200,000 requests per second. Now let's think about the right throughput. Every viewer of YouTube doesn't upload a video. So let's assume that on average, one video is being uploaded every 200 views. So videos being uploaded every single second on average would be views every second divided by views per video upload. So we are looking at 200 video uploads every second. To handle spikes, let's multiply it by 5 to handle 1000 video uploads per second. Now, let's figure out how much data we'll need to store for our platform. Let's assume on average around 10 hours worth of videos are being uploaded per second. To handle spikes in traffic, let's handle 5 times of this number up to 50 hours. Since we'll be storing videos in smaller streams, let's see how much size 1 second worth of video will be. We'll also need to store this video in various resolutions like 720p and 1080p. So on average, let's assume the size of 1 second of video will be 1 MB. For even higher quality videos like 4K and 8K, let's handle storage per second up to 5 times. So per second storage could go up to 5 MB. The total video storage now will be total number of hours multiplied by minutes per hour multiplied by seconds per minute divided by video size per second. So we're looking to store 40 GBs per second. To handle spikes of higher quality, we should handle this for 200 GBs per second. And lastly, let's think around the network bandwidth we need to scale this for. Since every second we assumed 1 MB upload per video, the total incoming bandwidth would be total video hours at seconds level. This comes out to be 36 GB per second. To handle spikes, we multiply this by 5 to handle 180 GBs per second. Now total outgoing bandwidth, meaning the videos being watched per second, would be the videos uploaded per second multiplied by number of views per video upload. 7200 GBs can be approximated to 7 TBs. To handle 5 times the traffic, we need to handle for 35 GBs of outgoing traffic per second. That is all for this section. If you didn't understand some of the calculation or conversions here, please refer to the estimate section of the lecture where I've covered this in depth, and then come back to this video.